the water. If we want to get together, that's a synthesis. You're building something. We're going to build a relationship. In order to build our relationship, I have to let go of my OH, and you have to let go of your H. Water came out. Now we're able to hold hands. Now we're bonded through a dehydration synthesis. We built something bigger than each of us. We're together. A hydrolysis. We're together. Well, we've decided we're thirsty and we need a parting of the ways. So how do we split up? We got to hold on to something. We'll grab our water. So a hydrolysis is a water splitting two molecules. A dehydration synthesis is remove the water, put the two molecules together. Okay? So it seems harder than it is. All right. We got that one. Okay. And one is the reverse of another. If I put us together, that's a synthesis. If I split us apart, that's a dehydration. If we're apart and we want to come together, that's synthesis. So one's the reverse of the other. All right. Okay. Saturated fats. Oh my goodness. Fat is how you store energy. Fats have 9 calories per gram. Carbohydrates have 4 calories per gram. So you eat your carbohydrates, you break them down, and if you eat too many carbohydrates, your body stores it as fat. I'm carrying 90 grams of fat. In those 90 grams, 9 calories, let's say. So I got 10 grams of fat on my body. Carbohydrates are only 4. If I have 90 grams of carbohydrates, divide 90 by 4. I got a lot more to carry around than fats. So fats have more calories per gram. It's concentrated energy storage. That's what fats are for, energy storage. We store our energy as fat because we're mobile creatures. And we need to have energy to do what we do every day. But if we were carrying around our extra energy as carbohydrates, we'd be 2.5 times, no, it's 4, yeah, we'd be 2.5 times bigger. If we stored our energy as carbohydrates, we'd be 2.5 times bigger. Because 9 is 4 times 2.5 is 9. So we'd be 2.5 times bigger if instead of storing fat, I stored carbohydrates. My thighs would be like out to here. It would be hard to walk that way. So fat is energy storage. It's a concentrated form of energy storage. Fats are usually solid at room temperature if they're saturated fats. Right? What do you know about saturated fats? Hello, butter. Hello, lard. Right? You take your butter out, and even at room temperature, your butter is pretty solid. Saturated fats are solid at room temperature. Fats are actually a short carbon chain, 3 carbons long, and then fatty acid chains coming off of that, which are chains of carbon, 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 carbon. If those chains are packed tightly together, that's what makes it solid. So saturated fats are solid fats, and what makes them solid is that they're tightly packed together. They're fully saturated with hydrogens. There's no double bonds. Every carbon has one bond to the other carbon, and H's coming off. It's saturated with H's, so there's no room for double bonds.